So, good morning, metabolites. Today we are going to look at the topic buffers under methods in biochemistry. Okay, without wasting much time, let's dive into what buffers are and their classifications and their components. First of all, we need to know that buffers are what? Buffers are solutions that resist change in pH upon addition of what? An acid or a base in minimum amount. So you see that buffers are very important. They are the ones that makes up the body. The body is made up of buffer solutions. The blood is buffered. The body fluids are buffered, so that any little amount of acid that goes in there cannot change the pH of the body. Because if the pH of the body change, it means that death straight. You understand? So that's what buffers are. So now, what makes up buffer? What constitutes buffer? Okay, so buffers are made up of either a weak acid and its conjugate base, or a weak base and its conjugate acid. So that's, first of all, we've talked about the definition of buffers. Secondly, the components of buffers. Okay, now a buffer is made up of either, as I said earlier, either a conjugate acid and weak base, or a weak acid and its conjugate base. So let's look at examples of buffer and its components. So first of all, let's look at a weak acid and its conjugate base. So who can give me an example here before we proceed? Okay, an example, a very good example is acetic acid and its conjugate base. So who knows acetic acid here before we write it down? Okay, I'm very sure some of us already know it. So let's proceed to the next. Acetic acid is like this, okay? CH3COOH. Now, when this disassociates, it will give you something like this, of this sort. So you have something like this. You have CH3OO minus plus H plus. Okay, now this is acetic acid, which is the weak acid. This is acetic acid, the weak acid. Then this is the conjugate base, and this is its proton. So now in this case, what will now make this a base, a buffer? This ionized conjugate base, if you add sodium hydroxide to it, if you add sodium hydroxide to this is what you have. Are you following? You have CH3OONA, while the hydroxy group will bind with this to give you water. So you have this plus water. You see? So there's no change in pH. Okay, now this is the main essence of a buffer. Now another example of buffer, this is the most common type. We have phosphate buffers. We have different types of buffers, and I'm giving you as an assignment, go and find out the type of buffers. Okay, so another component of buffer is a weak base and its conjugate acid. Examples of weak base and its conjugate acid are weak base and is what? Conjugate acid is ammonia NH3. Okay, NH3 plus H plus will give you NH4 plus. Now if you look at this, this is your weak base and this is your conjugate acid. All right, now the weak base accepts proton, while the conjugate acid donates proton. If you look at it, NH4 plus is a conjugate acid. All right, in this case, how does it is not very common The most common ones are the weak acid and their weak bases. Are we following? Hope it's simplified. Now, how do you this one? What happens in this one is that in the buffer solution, if something of an acid is added, this will donate its proton to it and stabilize the solution so that the pH will not change. On this note, we can proceed to what we call buffer capacity. All right. So what is buffer capacity? Buffer capacity. Can somebody from the congregation answer this question? What is buffer capacity? Buffer capacity is the ability of a buffer to resist change upon addition of a base or an acid. It is the amount of acid or base that can be added to a particular buffer to change the pH. That's the buffer capacity actually. How much of acid will you add? How much of base will you add to this particular buffer solution for its pH to change? That's actually what buffer solution is. Hope you understand. So, with that being said, let's look at how we can prepare a buffer. So we've talked about buffer capacity, and I know that most of us understand. If you don't understand, you can ask questions. Okay. Now let's look at what we call few calculations in buffer before we move further. So I like classes that have calculation because it's very interesting. Number one, how to prepare a buffer. Okay, how to prepare a buffer. The calculations involved, and the first calculation we are going to look at is this. Let's look at the questions quickly. How do you prepare a 1 liter buffer with 0.04 molar? Okay, 0.04 molar. You can see 0.04. Let's write out the parameters so that we can understand. First thing, 1 liter buffer, right? 1 liter buffer. How many? What's the concentration? Concentration is 0.04 molar. That's the concentration, right? Now, pH, with a pH of what? 7.5 and a pKa of what? 6. Forgive me. And a pKa of what? 6.69. Okay. Now, when you are provided with what? Phosphate buffers. Now, a weak acid of what? NaH2PO4. Okay, and a conjugate base Na2HPO4. Now you are also provided with these components. If you look at the question, where you are also provided with what? You're provided with hydrochloric acid, concentrated hydrochloric acid, and sodium hydroxide, and what? Sodium hydroxide. Now you get to know the meaning of all these things that are provided. You are seeing, right? You get to understand the meaning of all these things that are provided. So these are the parameters. First of all, in your exam, you need to write down the parameters. Okay, you write down the parameters and then you use them to solve. You can see your pH already. Okay, so let's proceed the calculation. Pay attention, everybody. So first of all, the formula we are using for this is what we call the Anderson-Hasselbalch equation. Okay, in our next class or in another of our class, we're going to derive that equation, how we can derive that equation. Okay, solution. First of all, you write down the Anderson-Hasselbalch equation, which is written as pH, okay, equals to pKa, follow me, plus log into A minus all over HA, where the A minus here is the conjugate base and the HA is the weak acid. It's a representation. Okay, now if you look at this question, which one is the weak acid and which one is the weak base? Let me give you a little expo. The one that has the highest amount of hydrogen is a weak acid because it can easily ionize, okay, an hydrogen proton. The one that has the less hydrogen is a conjugate base. So in this case, your conjugate base is this, while your weak acid is what? This. Okay, always know that. Do you understand? So let's proceed. pH here is what? 7.5. pKa is 6.69. all right, and the total volume is what? 0.04 molar, 1 liter buffer. So let's first of all do the little calculations here. How do we do that? First of all, pH is what? 7.5 equals to pKa is what? 6.69 plus log. Now that you've known the weak base and conjugate base and weak acid, you easily put them. Conjugate base is NH2, okay, Na2HPO4, right, all over NaH2PO4. Okay, easy, right? Can we proceed? 7.5. This now, if you want to take this 6.69 to this side, it becomes minus because yes, even though you are not saying it, this is plus this. Okay, so when you want to make this one subject of formula, so for you to do that, you have to do 7.5 minus 6.69 equals to log into what is normal Na2HPO4 all over what? All over Na, forgive me, all over NaH2PO4. Okay, now after you achieve this, the next thing you need to do, I'm taking it gradually, step by step, so that all of us can understand. All right, after you've done this, 7.5 minus 6.9, press your calculator. What do you have? Okay, some people have gotten it already. So after you've pressed your calculator, what do you have? You have what? 0. What? So we have 0. What? 0.81 equals to log, okay, into your weak acid and your weak base, that is Na2HPO4 all over what? All over NaH2PO4. Okay, now after you've gotten this, the next thing to do is to sort out this log that is here. If you remember in mathematics, if you have, this is just an instance, so if you have log 10 equals to any number 3, it is equivalent to 10 raised to the power of 3. Remember, this is log 10 from the beginning. Okay, so don't mistake. And in fact, if you see only log, it's log 10 also, so don't mistake it. Okay, so with this example, you can easily say that we can actually work this out. So don't forget this. Okay, don't forget this. You can easily work this out. Now this is log equals to 0. This is log equals to what? 0.81. so this means it's equals to 10 raised to the power of 0.81 with what you've seen here. Don't forget about this part yet. We are resolving this part actually. Okay, this part 0.81 equals to log 10. So how are we going to do that? Easily, we are going to resolve that by doing log, that is 10 raised to the power of what? 10 raised to the power of 8.1. And how do we do that? You have 10 raised to the power of 0.81 all equals to what? Your weak acid and your weak base. Okay, so you have Na2, my god, this is my light pen, H2, okay, PO4 all over NaH2PO4. all right, now after you've done this, let's press our calculators. 10 raised to the power of 0.81 is what? I think it's around what? 0. What? 10 raised to the power is 6.45. This, then if you approximate, what do you have? Let's respond though. If you approximate, let's say we have 6.646. okay, so let's take that 6.46. okay, we have 6.46 equals to this. Thank God for those that are following. Hope we are understanding. It's very easy. NaH2PO4. Now, how are we going to resolve this now? Easy peasy. You have this here, so you are going to find the ratio of both of them. How do you find the ratio? You put over 1 here. That means if you have this over this as numerator and denominator, you have this over this as numerator and denominator, that means it should be this ratio this ratio this. Okay, how do you do that? So easily we can say this, that if you have Na2HPO4 ratio NaH2PO4, it is equals to 6.46 ratio 1. Okay, so they are existing in this ratio. Then you find the total ratio, that is this 6.46 plus 1 to be 7.46. okay, I found the total ratio. Now you are going to get the individual concentration of this. Remember, the overall concentration they gave us what was 0.04 molar. Now how does these two concentration contribute or amount to this 0.04 molar? That's what we are going to find out now. Easily we are going to calculate. How do we do that? We easily say that this is the formula we use for this conjugate base. We are going to do this. Look, Na2HPO4, right? This one, we say that its ratio here is 6.46 now, since it's the first one and this is the first one. So you have 6.46 all over the total ratio, which is 7.46 times the total concentration, which is 0.04. Let's press our calculator to get the concentration of this. Okay, hope you are following. So we have 6.46 divided by 7.46 equals to, now if you look at what you get, you have 0. Are you following? You have 0.865999 now equals to. Now what I'll advise you to do, you divide, get your answer before you multiply. If not, you might get a wrong answer. Okay, are you following? If you don't do that, you get a wrong answer, so be precise. Okay, now when you get the answer of division, you say multiplied by 0.04. you approximate to 3 decimal places, and if you do that for this first one, what do you have? You have 0.035. okay, you have what? 0.035. if you are doing it accurately. Don't worry, we'll catch those that are not doing it accurately. We'll catch them. 0.035 for this one. Then the second one, let's calculate for the second one. Hope you're enjoying this class. The second one is NaH2PO4, right? Equals to, its own ratio is what? 1. So it will be 1 over 7.46 times 0.04. okay, so when you press your calculator, what do you have? You have 1 divided by 7.46 equals to, okay, times 0.04 equals to, what do you have? Some people are not following. Please follow suit. Okay, 1 divided by 7.46 which is equals to what? 0 point times 0.04. What's our answer? Your answer is 0.0053. okay, you are going to put it like that. Okay, you have 0.005. Are you following? You have 0.005. so add these two answers you've gotten. If it doesn't amount to this 0.04, it means that your answer and your calculation is wrong. So let's see those people that got it right. We have 0.035 plus, okay, now 0.005. we got it. Congratulations to all those that got it in their calculation. So the total, if you add these two, the total you will get is what? For those that are following, if you add these two, you have 0.035 plus 0.005 is equals to what? It is equals to our overall concentration, 0.04 molar. Take note, all these are the individual concentration, so you must put your molar. Then the overall concentration is also what? Do you understand? So we proceed. The next thing is to find out the concentration of each of these components. How do we do that? The concentration of each of these components. Now, that is where their masses comes in. The masses of this individual compound, I will show you how to get the masses so that when you are calculating for something different, you will still know what to do. All right, so can we proceed? The first one is sodium disodium phosphate buffer, which is a conjugate base, which is Na2HPO4. Now we're going to multiply their individual molars with their masses to get their actual grams, their individual masses rather, and their concentrations. So for we to get the concentration of this, we need to find the molecular mass of this, and you know sodium is 23, so it will be 23 times 2. Don't worry, in your exam they will give you the masses, so but you need to understand where they are coming from. Plus hydrogen is 1 plus 1, phosphorus is 31. Okay, so it will be 31 plus oxygen is what? The atomic mass for oxygen is what? 16. So it's 16 times 6. You are seeing it, right? We're having 16 times 4 rather. So add all of them in your calculator. What do you have? You have 142. Okay, but in general, it's not up to that. It's 141 point something. Okay, it's 149 point something, but let's take it as 142 according to our calculation. Okay, it's still the same thing. Any mass they give you in your exam, you put that one. Okay, but for now, let's put what we got, 142. Okay, 142. Then let's do for the other one, which is what? The monosodium dihydrogen phosphate buffer. How do we do this? Sodium is 23. There's no 2 to multiply here. Plus hydrogen is 2. That means 1 times 2 is 2. Plus phosphorus is 31. Plus what? Oxygen, the same thing. 16 times 4. Okay. Now, press your calculator quickly. What do you have? For those that have already gotten it, we know that what we have is 1. Okay, let's press it together. 23 plus 2 plus 31 plus 16 times this is 68 plus 68. What do we have? Sorry, 64 rather. 16 times 4 is 64 plus 23 plus 31 plus 2. So we have 120. Actually, it will be around 119, but let's take our 120, our round figure for this. Okay. So now when we got this, we now do this. For the first one, disodium, what do we have as its concentration? We had 0.035 as its concentration times its mass, which is what? 100 and what? 142. So equals to what? 142 times 0.035. You have 4.97 grams. Okay. Then for the other one, the monosodium, what do we have? Monosodium, we have what? 0.005 times its mass, which is what? Molecular mass, which is 120. What do you have? If you calculate 120 times 0.005. Okay. What do you have? For those that are following, I have 120 times what? 0.005 is equals to what? 0.6 grams. Okay. So now you measure these particular grams in the laboratory in your analytical weighing balance. Okay. And then this is the last thing we are going to do. When you measure them, you put them into a volumetric flask. Okay. When you put them into a volumetric flask, because the question is, how do we prepare? So you are telling them how we prepare after your calculation. When you put them into a volumetric flask, after putting them into a volumetric flask, you put water. The liter they are telling you is 1 liter. So you put any amount of water and mix them. After you mix them, you test for the pH. Are you following? You test for the pH. When you test for the pH and the pH is not up to the 7.5 they prescribed, you add. When it's not up to, it's very significant. So you listen. When it's not up to, you add sodium hydroxide base, because that's what you are provided with, because this will increase the pH. But if it's more than the 7.5 pH, prescription that was in the question, what will you add? You will add hydrochloric acid to reduce it if it's more than. Do you understand? That's why these two are important in the question. And then after you have settled the pH, you make it up to the mark, the 1 liter mark with water. Do you understand? That's basically everything about this calculation. Thank you for watching this video.